The first topic that we're going to study in 8th grade math is real numbers, which are the kinds of numbers that are going to be in almost every math problem that you encounter in 8th grade. Now, real numbers can be broken up into different groups of numbers, and one of those groups is called rational numbers. These are an important type of numbers that are going to be in our problems this year. So to start this lesson, a little bit of vocabulary. There's a graphical organizer. The central concept is rational number, and then attached are these bubbles showing different forms that the rational number could take. Okay. Over here on the side of the notes page is the definition of a rational number. A rational number is a number that can be written as a ratio of two integers in which the denominator is not zero. You might want to put a star by this on your note page. It's important to learn that definition. Okay. Now, even though the definition refers to a rational number being written as a ratio of integers, and a common way to show a ratio is one number over another, like a fraction, there are other forms that the rational number could take. Fraction is only one of them. And so what this first part of the note page is asking you to do is to give two examples next to each bubble. So next to the bubble for fraction, make up two fractions. And next to the bubble for mixed number, make up two mixed numbers. And same for decimal and same for percent. These are all forms that a rational number can take. And here are my examples. I wrote down two fractions and two mixed numbers, two decimals, and two percents. Now, underneath the graphical organizer, you'll see the first key concept for today's lesson. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. This key concept gives us a procedure for changing fractions into decimals, and that procedure is to divide the numerator by the denominator. You might want to put a star by this on your note page. Okay. Now, there are some example problems below to practice this key concept. And the directions are: write each fraction or mixed number as a decimal. To do this, we're going to follow what the key concept is saying. Divide the numerator by the denominator. Okay. I'm going to work two of them on the video for your notes, and then after that I'll give you some time for you to try problem 3 and 4, and then the answer will be shown on the video. Okay. So starting with number 1, we have the fraction 5/8, and we're asked to write this as a decimal. We're going to do this by dividing the numerator by the denominator. So 5 divided by 8 with long division would look like this. 8 divides into 5. Okay. Well, 8 will not divide into 5. And so what we do is put a decimal point after the 5, then straight above that decimal point, put the decimal point again, add a 0 into the problem, and now instead of 5, there's a 50. And we can divide 8 into 50 6 times. 6 times 8 is 48. Subtract 2. Okay. Now add another 0 into the problem and bring that 0 straight down next to the 2 to create the number 20. 8 divides into 20. How about 2 times? 2 times 8 is 16. And subtract. That's 4. Okay. Let's add another 0 into the problem and bring that 0 down next to the 4. That creates the number 40. 8 divides into 40 5 times. And 5 times 8 is 40, and so when you subtract, that would create 0 as a remainder, and that tells us we're finished. And so the decimal 0.625 is the decimal version of 5/8. Okay. Now, as another example, here's problem 2. This time we have a mixed number, -1 and 2/3. In our answer, we know that it's going to begin with -1 and then the decimal point. But what we need to figure out using division is the decimal for the 2/3 part of this. Okay? So our answer is going to start -1 point, and now let's use long division and get a decimal for 2/3. So 3 divides into 2. Okay. Well, 3 is more than 2, so 3 won't divide into 2. So we put a decimal point, and then straight above this decimal point, put the decimal point, and then add a 0 into the problem to create the number 20. 3 divides into 20 6 times. 6 times 3 is 18. And subtract, that makes 2. Then we could add another 0 in there, drop it down next to the 2 to create 20 again. And 3 will divide into 20 6 times. 6 times 3 is going to make 18. When you subtract, it's 2. If you add another 0, that's another 20. And what's going to happen is this digit up here is going to continue to be a 6. It'll be 0.6, 6, 6, 6, and so on forever. So that 0.6 is repeating, and the way that you can show a repeating decimal is to put a bar on top of this digit. So for the fraction 2/3, the decimal is 0.6 repeating. Now remember, for this mixed number, we had already started to build our answer up above in this space. We already have the -1 point part, and now we know what to put after the decimal point. 6 repeating. So here in the circle is the decimal form of this mixed number. Now I'm going to ask that you try 3 and 4 yourself, and then in a bit the answer will be shown in the video. So here are the solutions to number 3 and 4. In number 3, the whole number 4 is in the final answer in front of the decimal point, and then long division could be used to find a decimal for the 13/25. In problem 4, this is also a mixed number, and so the whole number 3 is in front of the decimal point, and then long division was used to find 1 divided by 11. This one happened to create a repeating decimal. As you keep going on this, you're going to continue to get 09, 09, 09, and so on. And so the bar to show repeating goes over the chunk 09. And here's the answer in the circle. Now for problem 5, we have a situation from actually real life to show where these numbers come into play. Okay. So last season, Detroit Tigers first baseman Miguel Cabrera had 191 hits in 611 at-bats. To the nearest thousandth, find his batting average. Okay. So we can take these numbers and create a ratio from them. That's called a rational number. So 191 hits compared to, or out of, 611 at-bats. So this situation about Miguel Cabrera uses a rational number to get his hitting statistic. Okay. Now if we want to get this as a decimal, which is the way that baseball statistics are shown, we use our key concept of dividing the numerator by the denominator. So let's figure out what this is. Now there are times in math where using a calculator is definitely more efficient than trying to do things by hand. And to do long division by a 3-digit number can be a challenging thing. So let's pull out a calculator on this one. Okay, here's the calculator. And 191 divided by 611. Here's the decimal shown on the screen that the calculator gets for that. And we're asked to give this to the nearest thousandth. So to the right of a decimal point, this first number is in the tenths position. This number is the hundredths position. This number here, the 2, is in the thousandths position. And to round to the nearest thousandth, we actually have to look one number over to see if this is 5 or higher. And this number 6 is 5 or higher. That tells us that we're going to round this upwards. And so our answer for Cabrera's batting average is .313. In baseball, they'd say he has a .313 batting average. So what that key concept was about was if you have a fraction or a mixed number to begin with, you can change the form of that number into a decimal form, because there would be times where a decimal form would be more appropriate for the situation that you're working with. One thing that immediately comes to mind is any problems that involve money. It's common to use decimals when you're working with dollars and cents, and not to use fractions or mixed numbers when you're working with dollars and cents. Okay. Now, moving to the next page of the notes, there's another key concept that we're going to work with. This still has to do with rational numbers. Okay. Key concept: a terminating decimal can be written as a fraction if you use a denominator of 10 or 100 or 1,000 or 10,000 and so on. Okay. So this key concept is about taking decimals, as you see on these example problems, and writing them as fractions, so sort of the reverse process of what we just worked with. Okay, so I'm going to do 2 of the examples for you on the notes, and then ask that you work on the next 2 on your own, and then the answer will be shown on the video. So problem 6, 0.4. Write this decimal as a fraction in simplest form. Okay. Now, using the key concept, we're going to change decimals that terminate, that is, they end after a certain number of spots and they do not have a repeating symbol on them. We're going to change them into fractions by using a denominator that is a 10 or a 100 and so on. Okay. So what is the appropriate denominator to use here when there's one digit to the right of the dot? Well, this one digit has a name. This is the 10th position. And so writing this as a fraction is as straightforward as saying 4/10 or 4 over 10. Now, the directions do say to write this in simplest form. You probably know this as reducing the fraction. And so our question that we need to consider is, does 4/10 reduce? When I look at 4/10, I notice that the top and bottom are both even numbers, and so to my mind that means I can divide them by 2 to make them smaller. So I'm going to divide this by 2 and divide the 10 by 2, and that will create 2 over 5. So that is my simplest form for the decimal 0.4. Now problem 7. Okay. Here we have the decimal 0.45, and we're asked to write this as a fraction in simplest form. Okay. Our key concept tells us we're going to use either a 10 or a 100 or a 1,000 and so on as our denominator. So what should be the denominator here? Again, these places to the right of the dot all have names. The first place over is the 10th position. This one is the 100th position. So writing a fraction is as straightforward as writing 45 over 100. Okay. Now again, the directions say simplest form, so does this reduce? Well, this number ends in 5 and this ends in 0, and to me that means I can divide them by 5. And so if I divide the numerator by 5 and the denominator by 5, I can reduce this fraction. 45 divided by 5 is 9. 100 divided by 5 is 20. And so 9/20 is the fraction in simplest form for this decimal. So please do number 8 and 9 on your own, and then the answer will be shown in the video in a bit. And here are the answers to 8 and 9. Notice that number 8 has a number to the left of the decimal point, and from that we will get a mixed number. So here is the 2, the whole number part, and then the 2-digit chunk uses a denominator of 100. Okay. On problem 9, this time this is a negative decimal, and so as I created my fraction, I was careful to put the negative at the beginning. Put the negative at the beginning. I don't want to lose the negative along the way and suddenly get a positive fraction for a number that was negative to begin with. Now there's one more key concept in this lesson that still has to do with rational numbers and the various forms that rational numbers can take. A repeating decimal can be written as a fraction if you use a denominator that's a 9 or a 99 or a 999 and so on. Okay? So what this key concept is about is what to do if you have the repeating decimals with the repeating bar above the digit and there's a need to change them to the fraction form. Okay? So again, I'm going to work out an example and then ask you to do the following example, and the answer will be shown on screen. Okay. So starting with number 10, here we have the decimal 0.5 repeating. Now the meaning of this is that this decimal is really 0.55555 and so on forever. And so there's not really just one number to the right of the dot, which would be the 10th position, so you can't use 10 as the denominator. And similarly, it doesn't mean 0.55 and then it terminates after 2 spots, which would be a 100 for the denominator. It's not any of those. It's so we need to do something else to find the fraction for this. Now I'm going to work out how you get the fraction for this using some algebra. And it's later in the year where we're going to learn a lot more about algebra. So for today, I'm going to show some algebra just to provide a reason why the denominator why the denominator is what it turns out to be. But if you then remember what happens here, you yourself won't have to do any algebra to do these problems. It won't be till later in the year where you do some algebra. Okay? What I'm going to do to get a fraction for this is create an equation. In my equation, I'm going to choose the variable n to represent the meaning of this decimal. So I'm going to write n equals, and then 0.555, and then because the 5 continues forever, I'm going to write ... which is a symbol used to mean n continues forever. Okay? Now the next thing I'm going to do is multiply my equation by the number 10. And when you multiply equations in algebra, you multiply both sides of the equation by the same number. So I'm going to multiply this side by 10, and that will create 10n. And I'm also going to multiply the right side of the equation by 10. Now when you multiply a decimal number by 10, a fast way to do that is to move the decimal point one spot to the right to create the answer. And that's going to create 5 point, and then 5, 5, 5, ... Now I'm going to do another algebra step with my equation. I'm going to subtract the original equation that had the letter n from the one that I just made. So underneath, subtract n equals 0.555 ... Now let's see what we get when we subtract these. To the left side of the equals, 10n subtract n, or another way to say that, 10n subtract 1n is 9n. And on the right side of the equals, when you subtract, all of these places that match each other, when you subtract, are going to create 0, right? 5 subtract 5 is 0. 5 subtract 5 is 0. Even all these dots meant 5. Now the one thing that will not make 0 when you subtract is this part. 5 subtract 0 makes 5. And so we have the equation 9n is equal to 5. We can solve this equation by dividing both sides by 9. That makes this 9 cancel away. The letter n is now alone, and we now know an answer for the letter n, 5/9. And that is our fraction for this repeating decimal. And so as we could see in the key concept, repeating decimals can be written as fractions if you use a denominator that is a 9 or a 99 sometimes, or sometimes you need to use a 999, and so on. In this case, we needed a denominator that was a 9. Now I'm going to ask that you try number 11 on your own, not by doing the algebra out, but by deciding what would be an appropriate denominator to use for this decimal. So look at the key concept and come up with a fraction for this decimal. And here is the answer to number 11. There was one digit in the repeating chunk, and so I chose to use a 9 as the denominator and had 3/9. Now 3/9 does reduce, and so I divided top and bottom by 3 to get the final answer, 1/3. Now 1/3 is a very common fraction that we'll encounter in math class, and memorizing that the fraction 1/3 is equivalent to the decimal 0.3 repeating could be a helpful thing for you to remember this year. It could save you a lot of time in future problems. Now the next one, problem 12. I'm going to work this one out on the paper using some algebra. That's going to just provide you the foundation for why the denominator turns out to be what it is. And then I'm going to ask that you try 13 on your own. So here we go. We're going to work on problem 12. Okay. We have the decimal 0.18 repeating, where the repeating chunk has 2 digits in it, and we want to get a fraction for this. Okay. I'm going to make an equation, again using the letter n to represent the true meaning of this decimal. So n is 0.181818 because the 1/8 continues forever. Now I'm going to multiply both sides of the equation, not by 10 this time, but by 100. And that's going to create 100n equals, when you have a decimal number and you want to multiply by 100, a quick way to do that is to move the decimal point 2 positions to the right. And that's going to create 18 point, and then 181818 ... And now, like last time, let's subtract the original equation that had the letter n in it from this equation we just made. So subtract n equals 0.181818 ... What does this make when we subtract? 100n subtract an n is 99n. And to the right side, all of these digits that match each other when you subtract them are going to make 0. And the one part that doesn't make 0 is 18 take away 0. That makes 18. To solve an equation where there's a number right in front of the variable, you can use division. So divide by 99, divide by 99. The 99s cancel away, and we're left with n equals 18 over 99. And that perfectly fits our key concept that repeating decimals are going to create fractions that have these numbers as the denominators. Now, 18 over 99 is a fraction, but it's not simplified. There is a number that will divide top and bottom. Let's do that so that we get this reduced. Okay. We can divide 18 and 99 by 9. So divide this by 9, divide this by 9, and let's see what we get. 18 divided by 9 is 2. 99 divided by 9 is 11, and so the fraction 2/11 is the simplified fraction for this decimal. Okay. Now, I'm going to ask that you take that idea and try problem 13 on your own. Again, you don't need to work out all the algebra, just take the concept of what denominator you need to use to get a fraction for this decimal. And there's the answer to number 13. This time there was a number in front of the decimal point, so I knew I had a mixed number answer, and I was careful to put the whole number here so that I didn't lose it. And then for the repeating chunk that was 2 digits long, I used 99 as my denominator. Now 27 over 99 does reduce, and so I reduced them to get this final mixed number. So that is the final piece to today's lesson. It was all about rational numbers, which are one kind of real numbers, which are the numbers that we're going to use in 8th grade math all year. And the concepts here today were how you can change the different forms of rational numbers back and forth. We changed fractions into decimals, and we also did a little bit of practice changing decimals into fractions.